Alright, I want to talk in this video more on the principles of circular motion, but specifically how might we apply Newton's second law to situations that are in circular motion. In this video I'm going to talk more about some maybe general forces, and then in another video or maybe in class we will look at specific concrete examples that apply the principles of this video. But let's say we have an object that is moving in a circle. And we'll draw it at, and we'll say this is a counterclockwise circle from our perspective. And we'll say that it's moving with a constant speed. And I should emphasize that does not mean a constant velocity, because we know we have an acceleration because we're moving in a circle. So the constant speed means not faster or slower, but the fact that the direction of the velocity is changing, well, that still counts as a velocity change. And so that's the motion of this object here. It's moving around something like that. And let's say the forces that are acting on this object, I'm actually going to redraw it now and just draw the forces, right? We don't want to have velocity arrows on our free body diagrams. That's still going to apply here. I'm only going to draw it in, I'll draw it in a few places. Let's say the force, there's three forces acting on this object. There's a force 1 and a force 2, both pointing in. And the strength of those forces is not changing, but their direction is always pointing toward the center of the circle. And then there's a third force. It's tiny, but it's pointing away from the center of the circle. We can see that even with these three forces, that the net force, we can see that the sum of the forces in the radial direction is toward center of circle. And I want to emphasize that this term, what it means is the net force in radial r direction. Remember that reference frame from the last video that we're using. We're using a rotating reference frame that at any one snapshot, we're looking at the radial and tangential directions. So that looks like, for the bottom left picture here, an axis pointing toward the center of the circle and then an axis tangent to it. For the bottom right picture, that reference frame is now rotated, and those are our axes. For the top picture, that reference frame is rotated again, and there are our axes. So the reference frame is rotating with the object as it moves around this circle. Notice that we don't have any forces in the direction of the velocity. We don't need anything to make it faster or slower. We just need a force that will allow it to continue to move in that circle. That's even worth writing down. No force in tangential direction, because we are not getting faster or slower. So all the forces are doing here is just changing the direction, not changing the speed. How would we apply this? Well, the sum of the forces in the radial direction, then, that's going to be equal to, we're going to say the inward forces minus the outward forces. This would be the same as doing right minus left in the x direction or up minus down in the y direction, but now we're using a different reference frame. And so what that's going to look like in this sort of abstract example is going to be the sum of the forces is F1 plus F2. Both of those are in the inward direction toward the center of the circle, minus F3, which points outward away from the center of the circle. And that would be the sum of the forces in the radial direction for this system. We'll continue this example in the next video where we'll look at the acceleration part of this.